Hello from a bitterly cold shed in North London. This is Logic Sheet 4. I'm going to go through the solutions, and this sheet we introduced this funny upside down V and this logical and symbol, P and Q. And so of course the two things you need to know when you step back and think about it, the two things you need to know to prove things involving P and Q is firstly, you need to know how to make a goal of the form P and Q, and secondly, you need to know what to do if you've got a hypothesis of the form P and Q. And the two tactics that deal with that are the split tactic and the cases tactic. So let me just show you those in action. So what's going on here? Our first question, we've got to prove that P and Q implies P. So we could intro H, P and Q. That might be a good name for it. And so now, of course, the big question is how are we going to get a proof of P? So we've got a proof of P and Q. So this somehow must give us a proof of P and a proof of Q. And the question is how? And it's the cases tactic. Cases H, P and Q with H, P, H, Q. And there you go. Now you see H, P and Q, that hypothesis that P and Q is true is gone. It's sort of been destroyed by the cases tactic. But it's been replaced by a proof that P is true and a proof that Q is true. So now we can just do exact HP. So that's how we're going to be using the cases tactic in this video. And in fact, if you do intro then cases, there's a shortcut for intro then cases. It's Rintro. Let me just show you the shorter way of doing it for this one. If I do Rintro HP HQ. There, then do you see that's done exactly the same thing? What we did in two lines here, intro and then cases, we can do it in one line with Rintro. So there's Rintro HPHQ, and now exact HQ will solve the goal as well as the assumption tactic. Assumption tactic just means the goal is currently one of our assumptions. So this one, what are we going to do here? We could do Rintro again, Rintro HPQR. And then the pointies HPHQ. Oh, to get those pointy brackets, I'm doing slash less than and slash greater than. So there's a quick way of doing everything. And now we've got to prove R, so we could apply HPQR. We could do it like this: apply HPQR. And now we've got two goals. We've got to prove P and we've got to prove Q, and both of those are assumptions. So we could do this. You see, assumption, that would work. But we could be slightly cleverer, if you like, and apply PQR semicolon, and then we only have to put assumption once. The semicolon instead of the comma means apply the next tactic to all the goals created by this tactic. So there's a solution to that. What are we doing here? So now I guess I intro. We're trying to prove that P implies something. Remember the brackets go around here. We're trying to prove P implies something. So let's assume P is true. Intro HP. And now let's assume Q is true. Intro HQ. And now we've got to prove P and Q. One way of doing that is the split tactic. If I do the split tactic, then you see I used to have one goal and now I've got two goals. And one of the goals is P and one of the goals is Q. So you see cases is what you do if you have P and Q as an assumption, but if you have P and Q as a goal, then the split tactic is the go-to tactic. So this is exact HP. Look, I'll exact HQ. That's the coders tell me that this is the way. The moment you have two goals, you should use these squiggly brackets and just separate these things off into two. You see in here we've only got one goal, and in here we've only got one goal. And is symmetric. So we could just be, we could do intro and then cases and then split and then exact and then exact. But let me just do this I could do this in two lines, right? I could do Rintro HP HQ, and then for this one the pointies work here as well there, so you don't actually have to use the split tactic at all. We can just we can just build the goal completely using those pointy brackets again. So P implies P and true. Intro HP. Let's split this one. So now here I've got to prove P, and here I've got to prove true. So I can do that with trivial, with triv. There we go. False implies P and false. Intro. So again, so I could use. I mean, the moment I have H, forget about split. I could just do X falso now, right? And then exact H. So that would be one way of doing it. Another way of doing it, actually, while I'm here, you can do cases H. Cases H actually finishes. There's a funny proof. The reason cases H finishes it is because there aren't any proofs of false, and so there aren't any cases. I rather like that proof, but perhaps for the official solutions, I should do it like this. There. And is transitive, so I guess we could Rintro HP HQ and then HQ. Well, I don't need that one, right? That I'm just putting a dash because I don't need that proof. That would be a second proof of HQ, and then exact HP HR. That would work. There we go. And now this one. This is the opposite to this one we did earlier. There. This example here and this one here. Let me just cut and paste that one. There. These two examples show that these two things are logically equivalent. This weird P implies Q implies R that mathematicians would never write, and this P and Q implies R, you can see that they're actually the same. We're proving that each one implies the other one. So let's get on. So Rintro. No. Do we need Rintro? We don't need Rintro. We can just do intros. HP and Q implies R. HP and HQ. I think, will that work? There we go. Great. And now we've got to prove R. So apply HPQ. Why did I call it this? Let's call it H. Let's call it H. Apply H. And now we've got to prove P and Q, but we've got P and Q, so we could do split assumption. There we go. I guess I've done all. You see, I've got no warnings and no errors, and so I must be done. So that must be the end of this video.